AI makes a shocking discovery. The universe is made up of just two elementary particles. Here is why. Elementary according to SM. According to the Standard Model, a particle is elementary if its composition is not known. This definition is unusual. There are 17 elementary particles. Elementary according to XM. According to the Xijidong non-standard model, a particle is elementary if it cannot be decomposed into another element. This definition is physically logical. There are two elementary particles, photon and pure electric charge. Composition of particles. 1. Electron and positron. Each is composed of a pure electric charge and a photon. Electron is composed of a pure electric charge minus and a photon minus, and the positron is composed of a pure electric charge plus and a photon plus. Composition of particles. 2. Neutrino. A neutrino is composed of an electron and a positron. The electron revolves around the positron and vice versa. This rotation neutralizes its electrical polarity towards the outside world. Symbol of the charge net. Such a compound particle is called a charge net. Its geometric structure is modeled as a disk of radius r depending on V, with a certain thickness. There are different energy levels. 3. Quark up. It is composed of a positron and 3 charge net of 2 energy levels, 2 with V and 1 with 3V. The 3 charge nets form a looped chain called chrominate up. Such a compound particle corresponds to a up quark. Its geometric structure is modeled as a triangle, each side of which is a disk, and the positron is located at the center. Here is a up quark symbol. Dynamic link. There are 3 contact points where an electron and a positron meet cyclically. It is possible to demonstrate that such a bond is stable. See the website https non-standardmodel.org. 4. chrominate up. At each vertex of the triangle there are points of contact. Electron and positron meet there in synchronization. The electric force helps stabilize the triangular structure. Here is the symbol of the chrominate up. A chrominate up is just a quark up without the positron in the center. 5. Quark down. It is composed of an electron and 3 charge-nets of 2 energy levels, 1 with V and 2 with 3V. V is the speed of the orbital rotation. The 3 charge nets form a looped chain called chrominate down. Such a combined particle corresponds to a down quark. Its geometric structure is modeled as a triangle, each side of which is a disk, and the electron is located at the center. Here is the down quark symbol. 6. Chrominate down. The up and down chrominates are neutral. At each vertex of the triangle there is a point of contact. An electron and a positron meet there in synchronization. The electric force helps stabilize the triangular structure. Here is the chrominate down symbol. A chrominate down is the down quark without the electron in the center. 7. Proton P+. It is composed of 2 up quarks and 1 down quark. A induced down chrominate is located in the center. Such a compound particle corresponds to a P plus proton. Its geometric structure is modeled as 3 quarks forming a chain whose center is an induced down chrominate. Here is a symbol of a proton. 8. Neutron. It is composed of a quark up and 2 down quarks. An induced quark up is located at the center. Such a compound particle corresponds to a neutron. Its geometric structure is modeled as 3 quarks forming a chain whose center is an induced 4th quark. Here is the symbol of a neutron. 9. Nucleonate up. It is composed of 2 up chrominates and 1 down chrominate. An induced down chrominate is located in the center. Nucleonate up symbol is given here. Such a compound particle corresponds to 1 nucleonate up. Its geometric structure is modeled as 3 chrominates forming a chain whose center is a 4th induced chrominate. A nucleonate up is just a a quark up proton without free charge, electric charge. 10. Nucleonet down. It is composed of one up chrominate and two down chrominate. An induced up chrominate is located in the center. It is just a neutron without free charge, free electric charge. Here is the nucleonet down symbol. Bond between nucleons. Axial bond between nucleons. It is established between a proton and a neutron. An axial bond is static with negative energy. Such a bond consists of three pairs of electrical charge of opposite signs. 11. Deuterium is an example of this bond. Bonds between nucleons. Radio binding between nucleons. It is established between two axial proton-neutron pairs. A radio bond is static with negative energy. Such a bond consists of four pairs of electric charges of opposite sign. 12. Helium is an example of this bond. Bond between nucleons. Dynamic binding between nucleons. It is established between two parallel nucleons. A dynamic bond is a positive energy. Such a bond consists of 8 pairs of electric charges of opposite sign. These charges are rotating in charge-net orbits. Each pair of charges meets at a point of contact once per period. All the charge-nets are rotating in sync. Bond between nucleonates. Dynamic connections between nucleonates. It is identical to that between two nucleons. Such a bond consists of 8 pairs of electric charges of opposite signs. These charges are rotating in charge-net orbit. Each pair of charges meets at a point of contact once per period. All the charge-nets are rotating in sync. Composition of atomic nuclei. 13. Tritium nucleus. It is composed of 1 proton and 2 neutrons. Their connections are 2 axial of negative energy. Such bonds consist of 6 pairs of electrical charges of opposite signs. The proton is in the middle of this stack. 14. Nucleus of uranium-235. There are more neutrons than protons. This requires dynamic bonds. Mass measurements confirm the existence of dynamic bonds. energy is released when these bonds break. For more details, see the rest of this presentation in a separate video. Our website https nonstandardmodel.org. Our website http jax.dong.free.fr